All right, hi. How's everyone doing this morning?
Hey,
Good?
come on, you
All
guys
right.
can do better than that.
I know.
Are you fired up and ready to go? All right.
Hey, there you go. All right, everyone's a little sleepy this morning. Well, sitting with me is Tom Kalil, who is the Chief Innovation Officer at Schmidt Futures. And Tom used to be, worked in the Obama administration where he built an innovation toolkit. And so obviously knows a lot about the I word. So we have a number of questions from the audience, and I'm going to ask some questions because there's a lot to get to, and we have a limited time. So, the first thing I wanted to ask Tom is, one criteria for the moonshots you pursued at the White House were that they should be ambitious yet achievable. So, to some degree, these two criteria seem incompatible or in conflict. How do you balance these, and what's an example of an idea that fits that ambitious, achievable dynamic?
Sure. So I'll give one example that I worked on that President Obama announced in April 2013, which is the BRAIN initiative. So that initiative was designed to do for neuroscience what the Human Genome Project had done for genetics. And so one of the things that we looked for is those areas where something had changed about the world that led us to believe that the previously impossible was now possible, so that there was some fundamental scientific advance or technological change that led us to believe that something that might have been crazy 5 or 10 years ago was now within reach. So that's one way to balance them, is you can identify something that has changed about the world that leads us to believe that the previously impossible is now possible.
So there has to be some kind of precedent that's kind of lets
you. Yeah. So for example, you could say, it would be really cool if we could teleport. But unless you're talking about a photon, we have no idea about how to do that.
Right.
So, working on teleportation would be premature. But there was a sense from the scientific community that with the right type of investment, we could develop tools that would transform understanding of how the brain encodes and processes information. So how do 80 billion neurons and 100 trillion synapses interact to create all the amazing things that the human brain can do: learning, memory, perception, action, consciousness, those types of things.
And what are, if you could name 5, technologies or developments that we are ready for now? That there have been certain developments, as you say, that kind of have preceded this, that have made these achievable? Like the 5 kind of most transformative.
Sure. So, I think a more interesting question is, what are the areas where we need innovation, right? So as you look at the landscape of the major challenges that we face, not only in the United States, but around the world, what are some examples where we really need innovation and the scientific and technological foundation exists to work on those problems? So let me give you a couple examples. So we know that the economic costs of living in a post-penicillin world, that is a world in which antibiotics are no longer effective, would be $100 trillion. Because not only would we have many more people dying of infections, but our ability to do surgery would be greatly reduced as well. So that's an area where we need new antibiotics to deal with the problem of antibiotic resistance. So that's one area. Another area in the healthcare is that there's a growing belief that in addition to going after individual diseases associated with aging, like Alzheimer's, we should also be making a direct attack on the underlying factors that cause aging. So that's another area. Climate change is an area where we need, not only do we need carbon neutral technologies, we need carbon negative technologies. So we need technologies that are actually going to suck CO2 out of the atmosphere. So that's a third area. One area that I'm very interested in, where I don't think we have enough innovation, is how are we going to address the fact that non-college educated workers are seeing stagnant or declining real wages, and the potential that technological change could further reduce the demand for workers with relatively low skills. So one of the areas where Schmidt Futures is looking for innovation is what we're calling a unicorn for the middle class. So rather than the startup with a market cap of $1 billion, how could you increase the wages of 100,000 non-college educated workers by $10,000? So those are a couple of examples.
And at Schmidt Futures, what are some of the innovations what are some of the moonshots that you guys are working on? And what's the process for working on
So one I just mentioned, which is, so in the sort of idea for the unicorn for the middle class, we partnered with an organization called Jobs for the Future and just did a call for ideas, which is going to be finalized in December. So we'll see some of the ideas that came back in response to that.
And what's the process that you follow at Schmidt?
Yeah, so I think that you've got to be having a couple different types of conversations. So one is a conversation with the people who really understand a particular problem. How are we going to feed 10 billion people? How are we going to have a US economy that works for everyone, not just people who are living in Silicon Valley? How are we going to accelerate the transition to a low carbon economy? So there's, on the one hand, you want to talk to people who say, this is really a problem we're solving. And then you also want to be talking to the people who have some understanding of the advances in technology, like genome editing in the world of biology, like constellations of small sats that are taking a continually updated picture of the planet every 24 hours, like the people who are driving advances in AI and machine learning to say, are there new capabilities that we have to solve these problems that we didn't have before?
Right. And during your time in the Obama administration, you built, as we said before, this innovation toolkit. Within this kit, which techniques proved to be sort of most useful? And what do you think might be applicable to corporations?
Sure, yeah. So one question that we would ask people is, in the same way that President Kennedy decided we should put astronauts on the moon by the end of the decade and have them safely return, or that we sequenced the human genome, and not only did that, but drove down the cost of sequencing the human genome from $100 million for the first one to now well under $1,000. What are the similarly ambitious goals that we should be setting in the 21st century? So the idea of setting an ambitious goal and then trying to figure out what is the coalition that we would need to build in order to achieve that was one element of President Obama's innovation toolkit. And the reason I think that's relevant to companies is that this is no longer something that just governments are doing. So Google has set a goal of dramatically reducing the fatalities associated with traffic accidents with self-driving cars. Bill Gates wants to eradicate polio. The late Paul Allen had an initiative to map the brain. Elon Musk has said, I want to die on Mars, but not on impact. So his goal was make
He said some other things too.
humanity a multiplanetary species. And you might think, well, is this something that, Fortune 500 or Global 1000 companies can get involved in? Absolutely. So Progressive Insurance was the sponsor for the Automotive X Prize, which was demonstrating the ability to develop a car that would get 100 miles a gallon. If you think about companies in the food industry, as I said, a major challenge that we're going to face is that we need to feed 10 billion people, and we need to do so on a hotter, drier planet with more variable weather. And so you could imagine partnerships between the large multinational food companies on the one hand and these small biotech companies who are looking at increasing the amount of protein that we can produce per square acre by a factor of 10. So I see lots of opportunities, not just for Silicon Valley, but for mainstream companies to identify areas that relate to their core competencies, and they could be involved in one of these as well. We did a lot of work on open innovation. So the premise of this is something called Joy's Law, who said, no matter who you are, most of the smartest people work for someone else. So the idea is to be able to harness the expertise of people outside of your organization using things like open innovation and incentive prizes.
Yeah.
So those are a couple of examples.
So collaboration.
Yeah,
essentially.
absolutely.
Yeah. And then you're currently in a room with obviously full of executives who are looking to drive growth and change in their companies. Do you think an incentive approach is something that they can adopt? And if so, how would you suggest they get started if you have, from obviously smaller companies to larger companies?
Absolutely. So we see the emergence of a lot of platforms that are designed to help companies do this. So an example is Kaggle. Organizations are taking data sets that they have and being able to tap this global community of hundreds of thousands of data scientists and then say, here's the problem that we're trying to solve. What is it that you can do with the data that we currently have? The government would use platforms like Incentive. So I'll give you an example. So the Air Force had the following problem, which is they have a vehicle approaching a checkpoint. The vehicle is not slowing down, and they would like to have the vehicle stop without blowing up the vehicle and the occupant. So they put that problem out there, and the winning idea came from a retired mechanical engineer from Lima, Peru. So I guarantee you that had they, and they only had to pay $25,000. So I guarantee you had they used a traditional procurement process, they would have paid a lot more than $25,000.
Right.
They might not have gotten an answer, and it certainly would not have come from a retired mechanical engineer from Lima, Peru.
That's amazing. Yeah. That's really interesting. And what are 2 to 3 strategies or tactics to get companies started on that track?
Well, so I think that one of the things that we embraced, and by we I mean the science agencies like the National Science Foundation and the National Institutes of Health, the government sponsors a lot of research and development. So the NIH has a research budget of $35 billion a year. The NSF has a research budget of $8 billion a year. And a lot of those ideas are not moving from the lab to the market. So they started training scientists and engineers in the lean startup methodology. So the scientists and engineers were taught, you may think your invention is the greatest thing since sliced bread, and that it's clear that everyone is going to want it, but we actually want you to learn how to go out and talk to 100 potential customers and partners to find out whether this is something that anyone is interested in.
Right.
So the process of customer development, the business model canvas, which is what are the elements of a successful business model, and agile approaches to engineering. So those are things that are beginning to have a cultural change within the university research community that the federal government is supporting, because they're now, scientists and engineers are no longer saying, well, once I've published the paper, my work is done. But they actually now have the intellectual tools to go out and confirm whether or not the invention that they've developed is something that is the basis for startup or licensing the technology to an existing company. So that's a mechanism that has been pretty effective.
Yeah. It also feels like a lot of companies, especially in the Valley, need, I always describe it as sort of a reality check officer or sort of a bullshit detector officer.
Right.
Somebody who can come in and say, whoa, you're going to develop something like Facebook Live where you're going to have, do you realize that there'll be some things that people do that are kind of not good on that platform?
Right.
And maybe we should think about this and build in tools to prevent those from happening.
Well, so it's interesting that you mentioned it, because one is we are partnering with the Omidyar network, which was founded by Pierre Omidyar, founder of eBay, and Craig Newmark of Craigslist, to support something called the Responsible CS Initiative. And the idea is to get computer scientists at the undergraduate level to start thinking about these issues, so that when they become software engineers or data scientists, they've already been thinking about some of these issues. So, and Omidyar has developed something called the Ethical OS. And what it does is it walks you through a bunch of different examples of unintended consequences associated with the development of new technology. So an example would be the way that machine learning and AI works in many instances is that these algorithms are not programmed, they're trained. And if the training data that you're using is biased, then guess what? The algorithm is going to be biased as well. So that's an example. So trying to get people to have, now that we have more experience under our belt, it's no longer appropriate to say, well, I never could have known that it would be used for that, because we now have enough case studies of these unintended consequences so that we should be prepared to think about addressing those issues at the design stage.
And then we talked the other day about this question of what are the circumstances under which the identification of a goal creates this sort of self-fulfilling prophecy, and what would it mean to have that type of moonshot culture in your company or organization?
So I think a moonshot culture would be one in which a growing number of individuals and organizations are involved in the identification and pursuit of a ambitious goal. And I'll give you a couple of examples. So what might this mean for a university? Well, UCLA has decided that they are going to organize the campus around achieving two big goals. One is reducing the burden of disease associated with depression by 50%. And the other is making the LA region 100% sustainable as measured by energy, water, and biodiversity by 2050. So that's what universities are doing. Some universities, particularly engineering schools, are allowing students to organize their research, curriculum, international experiences, and entrepreneurial activities around one of the grand challenges identified by the National Academy of Engineering. So that's how universities could get involved. Companies, as I said, could get involved in one of these by saying, what's an area where there's an important unmet need that we could get involved in pursuing? So maybe we don't develop the technology, but we're one of the early adopters of the technology.
Right.
So you could see partnerships between large companies that have scale and go-to-market capabilities, partnering with startups. You see government agencies involved in the identification and pursuit of ambitious goals. So Department of Energy set one called Sunshot, which is by the end of the decade to make solar cheaper than coal, and they are on target to achieve that goal.
Is that still being funded?
Yeah.
This administration, yeah.
So the administration has proposed some cuts, but fortunately Congress has not been willing to go along with all the cuts that they have proposed. So to me, a moonshot culture would be, number one, that research universities, government agencies, large companies, startups, investors, philanthropists, and foundations are more systematically identifying opportunities where we really need innovation and where innovation is possible. So, to this question of how do you create a self-fulfilling prophecy, if you can tell people, something that we thought was previously impossible may now be within reach, then you can change the burden of proof from why would we do that? That sounds really hard, to if you're telling me we have a chance of doing that, then why aren't we doubling down on that? So Sean Parker, for example, even though we've had a war on cancer since 1971, recently decided to make a large philanthropic bet on cancer. And the reason he did that is that we can now engineer the white blood cells in your body to destroy tumors while leaving healthy cells untouched. And for some types of cancer and some patients, this is leading to long-lasting remission as opposed to the 3 to 6 month improvements in survival time that we've traditionally been seeing. So he said, well, maybe this is the time where if we can figure out why it works for some cancers and not others, that we could really move the needle on this. So to me, that's what a moonshot culture more people would be involved in the identification and pursuit, and the media would be celebrating the teams that are going after these. So, Dean Kamen, the guy who started First Robotics, said, in a free society, you get what you celebrate. And Tom Friedman of the New York Times a while ago observed that one of our problems is that in China, Bill Gates is Britney Spears, and in the United States, Britney Spears is Britney Spears. So I think Moonshot Culture would also involve shining more of a spotlight on the scientists, the engineers, and the entrepreneurs that are pursuing these moonshots.
Yeah, well, that's my responsibility.
Okay.
Partly. And now I want to talk a little bit about, I mean, you played a major role in the BRAIN Initiative, and which is much like the Human Genome Project in some ways, but for the mapping of the brain. So what was a key sort of internal challenge or even a mistake that you came across during the rollout of this project, and how did you address it?
Yeah, so again, the question we were asking the research community was, what are the areas where where the federal government should be doubling down? And I got contacted by Mi-Young Chun, who worked for the Kavli Foundation, and she said, we just organized this workshop that had a mix of neuroscientists and people in the physical sciences and engineering, and they came up with an idea that they're really excited about, which could transform our ability to understand the brain in action. So right now we have a missing middle. We can either measure the activity of a small number of neurons with high levels of detail, or we can take a fuzzy picture of your entire brain, but we don't have the tools that are necessary to understand the brain in action. So understand how a neural circuit that might be composed of 1 million neurons interacts in real time. And so the thought was that if we could develop those tools, several things would happen. One is our understanding of how the brain works would be transformed. Our understanding of how the brain encodes and processes information, number one. Number two, this could ultimately improve our ability to diagnose, treat, and prevent diseases of the brain. And number three, there could be new algorithms and computer architectures that are informed by how the brain works. So the supercomputers that we're building at current rates are going to require their own dedicated power plant. And the human brain uses 20 watts of energy. So clearly Mother Nature has figured out something about low power computing that engineers and computer scientists have not. When we train algorithms, sometimes we have to provide hundreds of thousands or even millions of examples. Your 5-year-old only has to learn once that touching a hot stove is a bad idea. So those are a couple of examples of how, by studying how the human brain works, that could transform how computing and algorithms in the future work. So that was really the motivation, and what it required was, again, building a coalition. So not only the National Institutes of Health, DARPA, the agency that developed the internet in the late 1960s, the National Science Foundation, IARPA, the Kavli Foundation, the Howard Hughes Medical Institute, and the Allen Institute. So it really required an all-hands-on-deck approach because there was no single entity that was in a position to pull this off because of its complexity.
Yeah. And were there challenges that were sort of not met in that process, or it still remained to be?
Yeah, I mean, I think one challenge is going to be this is something that is going to require sustained investment. So this is not something like, a couple years from now we're like, oh, we're done, we understand how the brain works. So our federal government is not always good at sustained support over decades. Something that I worked on that has had that level of support. So I worked on the National Nanotechnology Initiative, which President Clinton announced in January 2000. And that has survived the transition from Clinton to the Bush administration to Obama administration to the current administration. So it's been going on for 18 years. And my hope is that the BRAIN Initiative will also attract that same sort of sustained bipartisan support.
Excellent. All right, good. Well, I think we have to wrap it up. But any last thoughts or insights? Or?
Yeah, I'd be, I guess the main thing I would have is for the, Fortune 500 and Global 1000 companies that are in the audience, to not believe that these sort of moonshot projects are things that only Silicon Valley companies can work on. We need lots of innovation in the physical world, not just in the world of bits and bytes. And there are many opportunities, I think, for companies to get involved in something really ambitious and meaningful. And I think that is also going to be critical for attracting talent. So the very best people are more intrinsically motivated than they are extrinsically motivated. And so they not only want a paycheck, they want to work on something that they think is meaningful. And I think that this sort of identifying really ambitious goals is one way to recruit and retain top talent.
Excellent. All right.
Great.
And on that note, thank you.
Thank you.
And thanks.